try to tell you these three in couple of minutes, but with a different data set. So far in the subsetting area, we do not have any issues, right? If you have any doubts,
No,
we can
no
discuss.
issues.
Okay.
No,
Okay.
it's fine.
Let me just start with pre-processing. I'll close the unwanted files. We don't require it. Visualization also, it should be for the next class. Now I'll start with pre-processing. Okay. Before starting with pre-processing, I want to show you how the data looks like. So this is a folder. This is a Git folder which I cloned, and in data, I have something called as pre-processing. This is
Folder.
one new folder that I created with three different CSV files. Okay. And what we have is three different CSV files. One which is department data. I'll open and show. So what happens in department data is like we have couple of columns which tries to tell you what the department, like all the details about department. So let it just open. So when you open and see the department data, we have department ID, we have the department name, and we have who is the department head. Very simple. We do not have any null values here. But this is the master table. You can call it as a master table for department data. Usually, whatever you're seeing now as a CSV file, this could be a SQL table in most of the companies. Okay, whenever you have these tables are called as master tables because they have the master information, like on a very high level about what the department has. Similarly, you might have a master table for product, or you might have a master data for employee details. So for example, now I have employee details. So this speaks about employee as the name suggests. So I'll open and show what the employee details have. So employee details, it just says what is my employee ID, what is my age, what is the gender, and what is the marital status. As simple as that. Okay. This is also a master table. And then we have one transactional table. What happens in a transactional table is generally wherever you try to capture more finer granular details, that would be a transactional table. So for example, invoice, you're dealing with Amazon or Flipkart. Every day you're getting invoices. So that is a transactional table. In this transactional table, what are the master tables? Product is one master table which tells about what is a product the customer is going to choose. Say for example, a person is choosing iPhone, so iPhone is sitting in one master table. So the moment he clicks on the iPhone image, it will go and fetch all the details of that particular iPhone, and it shows on the UI screen. Similarly, when you go for the payment, so payment is also one of the master tables wherein they show like what are the different payment categories. You have a phone pay, you have Paytm, you have UPI, many other things, right? So you can imagine like for transactional tables it is different, and for master tables it is different. So in this case, now we have one transactional table wherein you see that there are a couple of finer details like average monthly hours, the department at which the record belongs to, and some other features like filed complaint, number of projects he or she has worked, what is a salary slab, whether it is medium or low or high, what is employee satisfaction, did the person leave or still with the company, and how many years did the company person stayed. Okay, this is the things that we have. If you already saw the data set, right? Now what we'll do is we'll try to
Yes.
load this data and complete the pre-processing stage. Okay. So we have already seen these two libraries like pandas and numpy. At a later point I'll explain you about plotly. This is for our next session where we deal with visualization. But now because we are already talking about pandas, and it's a good time for us to complete the pre-processing stage, so I'm just showing you how to do the pre-processing steps. Okay. So let us just
Okay.
import the necessary libraries like pandas and numpy for now. Maybe at a later point when we are applying models, we will use many other libraries. And now, so what I did is one simple function which just takes the path of the file and it simply returns the data frame by using read underscore CSV. So it is obvious that I'm going to choose only CSV path here. Okay. Because I have 3 files, I'm going to use 3 files here. So let me correct the correct location. So it is data pre-processing, and then we have employee data, and then we have employee details. So there are 3 different data frames. So let us take a look at each of the data frame, how it looks like. So first we'll look at department data. I'm going to press department dot head, and it says that we have department ID, department name, and department head. Okay, and you have different many other features like it tells about what is ID, what is the department name, and who is handling that department. Similarly, when you look at employee details, in employee details we have employee ID, age, gender, and marital status, as I showed you in the Excel file. And in employee data, we have many other features like what is the monthly hours, whether the person has given any complaint or not, what is the satisfaction, whether he got promotion or not, and so many other features. By looking at this data, you must have already figured out that there are a couple of common columns. Okay. Whenever we have common columns, and there is a possibility that we can use those columns for merging the data horizontally. So say, for example, in this case, you have employee ID here in employee data, and we also have employee ID in employee details. So if I merge this table with this table, what would happen is I would get the features like age, gender, and marital status to the merged data frame. So I'll show you how to do that. But so if you are already familiar with SQL and all, if not, I'll just show you. Say we have one data
No,
frame.
I'm fine. I'm fine.
Yeah, you're fine. But
I'm fine
yeah,
with
let's see.
SQL.
Okay, okay. So what I'm trying to say is that you have one join column, which is nothing but a common column. And wherever the column values are matching, say for example, you have 4 here, 3 here, and 1 here. So wherever the values are matching, the first record will go and touch the record where the value is 1. Similarly, 3 will go and touch with number 3. This is how the mapping is going to work. So I'm going to tell you how this will work in data frame. So let me clear this. Okay. And one other thing which you should also be seeing is that we have department ID here, and the same department ID or similar value as department ID should be somewhere. To say
Before field complaint.
before filed complaint, right? Where is it?
So
Oh,
left
okay.
side.
Sorry. Yeah, here it is. So you must have noticed that the pattern is almost same. Like for example, you have D00 followed by some 2 strings. Here also you have a D00 followed by 2 strings. So it means that in this case, you have a department as a column name, but the same value in another table is having a different column, which is the department ID. So just by looking at the data, we have to figure out that if there is any you have a common column with different names, even that you have to handle it. So how do you handle it is either by replacing one of the column names. Say for example, I want to go and replace in department data. I want to rename the column which is department ID to department. So what I'll be doing is I'll be replacing the columns. Okay, renaming the columns. So the syntax is very easy. Okay.
Yeah, hi Sanjeev.
Hey, hi. So when you look at the syntax, it is quite easy. 1 minute. So what we should be doing is we should be taking the data frame dot rename. When I say I'm telling the data frame that I'm going to rename something, like this is the syntax. In rename, I want to tell that I want to rename columns. So I'll specify columns. Okay, equal to, in this you will pass a dictionary of columns. So what is the actual name and what should be the next name? So this will be actual name, colon, new name.
Sanju, the machine learning మొదలెట్టింది
లేదు pre-processing.
Preprocessing. Okay.
Data frame, pandas data frame. So I'll just remove in place for now. I'll just show you what happens. Okay. So when I did that, it has renamed my column department ID with department. But when I go and show you department underscore data one more time, it is again showing us as department ID. So we have renamed it, but we did not assign it. So what we can do is we can either assign it like this, or I can say in place equal to 2.
Then in place is equal to. Okay.
Okay, when I do in place equal to true, it will just rename it. And then when I go and print head, you can notice that the department ID has been replaced as department. Okay, now this is the way to fetch columns, which you already know. And I want to see how many null records are there in each of the data frames. So for first is our department data. When I go and look at department data, I don't have any null values. Similarly, if I go and look at employee details, I don't have any null values. But when I look at the transactional table, this is where most of the null values are present. So when I look at the transactional table, you notice that there are so many null values. Okay. Now, this is the area where we are going to use subsetting, whichever we discussed so far, and going to replace one column at a time with a particular value. Now, the question is how to confine what should be the value with which we are going to replace. Now, that is a very good, important question. So far, I did not merge any of the data frames. They are all standing alone. Now, I want to get all of that data as one final data frame. So we'll do one at a time. So first step is I'm going to merge my employee data with my department data. There are a couple of things which we need to keep a track. I mean, keep a note. So merging two data frames. So how specifies whether it is inner or left or right, something like this. Mostly you'll find it as inner and left only. Right, we generally do not use. And on is all the join columns or common columns. Okay, this is
Merge is something like a join only, right? In a SQL.
in SQL, it is join, correct. In
Okay.
SQL, you have inner join, left join, right? It is the same thing.
Exactly.
Yeah. So what we're trying to do is I'm going to take employee data. I'm going to take employee data and I'm going to merge one data frame which is department data. Now, as I told you, department data is a master table. It has got only unique records, and in that unique records, it speaks about what is the department, what is the department ID, and who is leading the department. So I'll just join department data, and as you know, the common column is department. I'm going to say on equal to department, and how is equal to left. Now there is always a confusion between when to use left and when to use inner. Let us say when you're talking about this transactional table, I don't want to lose any records of this particular transactional table. Whichever is on my left side, I don't want to lose any of those records when I join it. In that cases, I want to use left. Say for on the other side, say for example, our intent here is to find out only those records which have a valid department. Say for example, your company is having like 5 departments, and there is one other in the transactional table, there is also some contractors there, okay, which are not belonging to your company, and you're not bothered what is going to happening with those records. Even if you lose those records, there is no problem for our machine learning problem. Okay, so in that cases you can do a inner join. So wherever the data is matching with my master table, only that data I'll go and pick. In that cases you will be using inner join. But in couple of cases you might not always see that you can scrap a couple of data. You might have a requirement that you should not be losing the data, and you should be getting all the information that is provided from the transactional table. In that cases, you will be using left join. Okay, so I'll just go back to left join, where it is. Yeah, here. So in this case, I'll be taking left join because I don't want to lose any data that is present in employee data. So what I'll do is, before doing join, let me keep a track of shape, print employee data dot shape. Okay, and I want to print the same shape after merge. Now, when I do that, you notice the number of records are same, but the number of columns have increased. This is a good sign. You don't want to increase the number of records because there is some duplicate value in the master table. So if at all there are duplicates, then you will end up with Cartesian products. So now what is a Cartesian product is? Like, for example, again, we have two data frames. 1 minute. This is very important topic. That's why I'm just pausing about this. Let us say that we have two data frames. And in this data frame, we have department one, and then department two. For some reason, the department one has two records. Okay, maybe all of them are same. Let us say that all of it, they are just duplicates. And then again, here also you have some values like 1, 1, 1, and then 2. Okay, and then 2. Now what happens is, because you have 3 ones here and 2 ones here, you will end up getting 6 ones, because 3 into 2, this becomes a Cartesian product. Only for department 1, you will have 6 records, where actually you are supposed to get only 3 records. But because you have a duplicate, you are getting up with 6 records. This is not something which should be happening. So whenever you go and notice that there is a change in number of records and that you don't anticipate that to happen, just go back to each of the data frame and find out whether you have any duplicates or not. It is okay to have duplicates in your left table, whichever is my left table. Like in this case, my left table has 3 ones. It is okay. But in my master table, you should not have any duplicates. Master table means one record for one instance. The same instance cannot have 2 records. So same department cannot have 2 records. Okay, always keep this in mind. So Cartesian product should be the first thing which should come to your mind when you notice different set of record count after you complete the merge. Okay, this is one thing. So I did left, and as you notice that in department I have department name and department owner, sorry, department head. Those two names have come. Okay, just keep this in mind. Wherever I do not have department, say for example, the first 2 records, I do not have any department. So what has happened? It did not join properly, and it created null values because it could not find the proper master for this. You don't have an AND record in master. That is why you don't get these values. So we'll treat this. Don't worry about that. But I'll let me continue around this. Okay. Now we merge 2 data frames. We are left out with one more data frame, which is nothing but the employee details. And if you remember, in employee details, we have employee ID. So here you have employee ID. Also in employee details, we have employee ID. So I'm going to use employee ID. Again, I'm going to use left to merge the records. Now let us see what is the shape. Employee data dot shape. Okay, again we have 14,150, which is obvious, 14,150, and different set of columns. This is a good sign. We don't have to worry about it. So let us say I'll just go and print one more time. So when you go and print, you can notice that we have new columns, which is the age, gender, and marital status. Now let us go and find out. This is our aggregate column, wherein you get all the values from multiple tables in one consolidated table. Okay, you can rename this table as a new data frame, but for now, because I don't want to lose the memory, I'm just putting it as employee data. I'm capturing all the other tables in the same data frame. Now, when I go and look at the number of null values, you see that there are a number of null values. Now, this is a very common question of how to treat these null values. So there are a couple of steps that we need to follow whenever you are replacing the null values. First step is to identify what kind of data that column has, whether it is a continuous column, whether it is a categorical column, whether it is a Boolean column, and so on. Now, when I say continuous, it means that it is having continuous values. Say, for example, you have uh, height of children in a given class. So some persons may be like 140 centimeters, some persons may be like 150 centimeters, and some persons may be like 130 centimeters, and so on. Like this is a continuous value. So you have a defined set of range. So the minimum range is say like 125 and maximum it went to 159, for example. Okay, so you have a defined range and the number of values are maybe you can have decimal values, you can have float values. So you can notice that these values are this continuous. Okay, on the other hand, if you have gender, say I have male and I have female for now. Like for example, if you have two genders, male and female, so they are defined set. It is having a limited count, only 1 and 2. So whenever there are limited number of features and the features are repeating in many number of times, it is highly likely that that column is a categorical column. This we call it as categorical column. Or in other words, it is just an object. But when you come to machine learning and when you try to apply this data types, we call this as a categorical data. And wherever you have categorical data, you will have to convert this to numbers, meaningful numbers. I'll tell you what meaningful numbers is at a later point. Similarly, let us say you have month, like say you have January to December. Again, it is a defined set of length. You have only 12 column, 12 distinct values, and like it can be any of the month from the year. Okay, or it can be, you can say quarters, like Q1 to Q4. This is also a categorical data because you have defined set of say for example different set of values Q1, Q2, Q3, or Q4. On the same hand, let us say for some reason you because just by chance you had in the continuous data you had only distinct values. Say I had only 143 times, 154 times, and 135 times. Just because this number of categories is 3, I cannot say that this is a categorical data. So you should be sharp enough by looking at the data and looking at the column name. You should be sharp enough to identify whether it should fall as a categorical data or it should fall as a continuous data. In the matter of height, in the matter of height, I can convert this as a categorical feature. Any thoughts how I can convert it? So if I have a continuous data and if I want to convert it to a categorical data, how to do that? You must have heard about binning. Okay, what I'll do is say I have a continuous data here wherein the values are ranging from 125 to 159 and there are so many different values. Okay, so I want to convert these values to 3 categories. One category is starting from 125 to say 140, which is my short category, and 140 to 150, which is my medium category, and 152 plus, which is my tall category. So I can convert a categorical data to I can convert a continuous data to categorical data by using binnings. So I can create different bins and assign each bin based on the value and where it belongs to. So if it belongs to the small category, we'll replace the value as small. And if it belongs to the medium category, we'll replace it as medium. And if it goes to the tall category, we'll replace it as tall. So just for now, just imagine that we have two types of columns. One is categorical and one is continuous. Okay. Now looking at this department, tell me if it is a categorical data or a continuous data. I'll show you how a department looks like. Now we have department here, or I can just show you the values. If I want to fetch only one column, I'll say department dot unique. Okay, now tell me if it is a categorical data or a continuous feature.
Categorical.
Yes, it is a categorical. Continuous, when I say, it should be first integer or a float value by default. Whenever you find string, it is by default a category. And
Category.
if the number of categories are very high, you can group them. As I told, similar to what we
Binnings.
did in binning, we can also group them. Say, for example, I want to group SP and MT as one new feature. So I can, wherever I have
Okay.
SP or MT, I'll go and replace those values to some other value. Okay, this is how I can do it. Now, just see that we have couple of null values in department and also a couple of values which are not having a prefix.
Yeah.
So this did not come as a null value for us. Okay, it is having a defined value, but this value is wrong. So how to treat it? So first time what I'll do is I'll just go and replace the ID one. So I already showed you the department counts. Okay, so we have department and we have the count. You notice that we have 707 null values in this particular column, and hyphen IT we have 207. When you notice hyphen IT, it should actually belong to this particular department. Agree or no? This could be a, say, typographical error from the data entry person, where he or she
Okay.
failed to understand that he
Yeah.
has to put
Basically, this is the IT department, and it should be start with the
D00.
D000. But
Correct.
unfortunately, they have
They did not
entered incorrect
put it.
data. Okay.
Correct. So first, what we'll do is I'll go and replace this hyphen IT to D00 IT. Now, just moments ago, I told you that we can subset the data and see. Say, for example, to subset the data, what I'll be using is I'll be using dot block followed by what is my condition, followed by what is the column that I want to fetch. Ask questions crisply and your syntax is very easy to understand. What is the data frame where I want to go and replace? What is the condition that I want to replace with? What is the column where I want to make this change? So the column name is department. Condition is department should be equal to hyphen IT. Let me go and fetch. So when I go and fetch, you can see that all of them are hyphen IT. Now, right side, I'm going to have a static value. It is very easy. So because it is a static value, it will not throw us any error. I'm going to simply go and say, just replace this hyphen IT with D00 IT. You can either use by subsetting or you can also use .str.replace.
Okay.
But there is a catch. When you go with .str.replace, it will not throw any error. The syntax is correct, but the output is wrong. Okay, I want you to, when you execute this notebook, I want you to go and try this and find out why this is not going to work. So one common thing why it will not work is because you have the same pattern in both wrong and correct records. This is my correct record, hyphen IT is present here as well. This is my wrong record, hyphen IT is present here as well. So when I go and replace hyphen IT, it will replace these records and also it will replace this record. You understood?
Yeah. Yeah.
So make sure that whenever you are using .str.replace, you should first subset and see if you really have only that particular records that you want to update, or you have some excess records which are not supposed to come there. Okay, I have already replaced it. Now what I'll go and do is I'll go into see value underscore counts. Now I do not have hyphen IT. It has went and it went correctly into D00 hyphen IT. Now I'm left with 707. Now here is a catch. This is a categorical data. This data of 707 records can be any of these records. Okay, or it can be some records can belong to engineering, some records can be belonging to IT, some records can be belonging to admin. Even that is also possibility. One obvious choice whenever you see this is to replace with mode. Mode is like what is the most frequent value. Now in this case, the most frequent value is SS. So my obvious choice is to replace all these 707 records with SS. But can we do something else other than replacing with mode? Okay, this is where data, this is where people get more sharper, right? By default, if you know only this pre-processing step, I want to go and replace with mode, I'll go and replace with mode. But if you go and replace with mode, maybe your model cannot identify the correct features. So you should be able to try out some other analysis. Should make another analysis to find out what are the other possibilities if I replace this particular value other than the mode. So I want to try that out. Okay. So what I'll do is I'll just show you. I think this is not required. Also, this is not required now. First, I'll do a group by, and I want to figure out what is my average monthly hours. Now I'll tell you why I'm doing this. Okay. So for example, you run a company. You have couple of categories in your company. One category is your worker category, which is like a blue collar job, and he or she works 12 hours. 8 hours is a normal shift and 4 hours is OT by default. On any given day, most of the people in that particular department do OT, like 3 hours or 4 hours. Okay, that is one particular category. In the same company, you have admin job, wherein they usually come at for 8 hours and they go away, the admin job. And you have some production team wherein they tend to extend couple of hours, maybe not exactly like 4 hours or 3 hours, but usually in this particular department, average 1 hour or 2 hours is excess. So based on the average monthly hours, without looking at my department, can I figure out which department this particular guy is coming from? So the same intuition I used it here. Because I'm talking about average monthly hours, I want to fetch what is my mean, what is the count, what is the unique number of values present in that particular working hours, and what is the max value and what is the min value. So how do I do that? I simply group by on department, and I want to get, for average monthly hours, I want to get all these features. So notice
Okay.
there's a new syntax that we're discussing about. I'm trying to group by on department. So when you group by on department, what happens is it merges into one index. Say, for example, you have a transactional table. You have 1, 1, 2, 2, 2, 3, and 3. Let us say that this is your transactional table. When I group by on this particular column, it'll try to first create index. It'll create index 1, it'll create index 2, it'll create index 3. So this 8 records will become only 3 records. Whichever is the number of unique values, that many records you'll find it. Okay, this is the first thing in group by. Now, after doing a group by, what are you doing? After doing a group by, I want to aggregate couple of columns. So in aggregate, dot aggregate, I'm going to fetch one column, average monthly hours, and I want to create on this column, I want to find what is the mean for a given department. So what is the mean for department 1? What is the mean for department 2? What is the mean for department 3? Similarly, I want to get what is the max, what is the min. So if I want to get multiple features in same group by, I can pass a list of functions. These are all functions in pandas. Mean is a function, count is a function, n unique is a function, max is a function, min is a function. You have many other functions. You have list also. So you can try to list all of them. Okay. So what I'm saying is might not be important. Okay. You can, if you're comfortable with replacing with mode, you can always try that. But I want to find out some other patterns from the data set. So what I did as I did a group by on department, and for average monthly hours, I took all my data. What is my mean? What is my count? What is my n unique? What is my max and min? Now look at nan values. Okay. Specifically, it has a minimum value of 98 and the maximum value of 310. Okay. And the mean is somewhere around 199. So looking at this data, what is the obvious choice that you can think of? Now, 310 and 98, you see this 310, 98 here.
PD. PD.
Correct. Any other column that you find, any other column that it is matching?
No.
It is not
It's
matching, right?
above or below.
Yeah, it is either above or below. So this is something like a fingerprint. Like, your data is trying to
Yeah.
tell you something. It is for us to identify what to extract from the data. If you're unable to find that pattern, we might miss it. So we will have to try n number of different combinations to come up with this conclusion. As I said, like by default, I can go and replace with SS. But if I had to replace with SS, you see the minimum is 96, and here the minimum is 98, and the average is around 200, 201, and the average here is 199. See, here it is 199, and here also it is almost like 199 point something. It's almost same. It is like very close to this particular department as compared to this particular department. Okay. So what I'll do is
Sanjay,
wherever.
here is my question. An
Mhm.
example here, since we have less department numbers, we can see on the screen and we can identify. If there are more number of departments, like more than 1,000, 2,000, 10,000, in that scenario, how do we identify those
So
this
in yeah,
condition?
correct. In that case, what we have to do is like you have to go with the mode. See, when you can, when there is a possibility for you to dive deep into the data set and extract this feature, it is good. You can try it. You should really try it out. But given a case when the number of features are too many number of features, and you cannot identify which is important, which is not important, then to begin with, you have to go with the mode value.
ఆ సినారియోలో ఇది యావరేజ్ అసెండింగ్ డిసెండింగ్ కౌంట్ కానీ మీన్ కానీ ఇలా పెట్టుకొని ఒకదాని తర్వాత ఒకసారి ఒకటి వస్తుంది కదా, అప్పుడు చూడొచ్చా మరి?
చూడొచ్చు. కావాలంటే you can sort the values and then find out.
సార్ట్ చేసుకొని కూడా చూడొచ్చు కదా?
చూడొచ్చు. You can do it. You can sort it on this particular thing. So in this case, నేను group by చేసి నేను reset index కొట్టలేదు, అందుకే మీకు dual index కనిపిస్తుంది. But if you want, you can just go and reset the index and sort on maximum or minimum, and then you can do it. I'll also tell you about sort in a couple of minutes, but for now, I did a group by, and looking at the data set, I can say that all the null values should belong to the PD department.
Exactly.
Okay. Now what I'll do is, again, I'll use dot log. What is the condition at which I want to change, what is the column I want to change, and what is the value I want to change, and I'll simply go and replace it. Now because you have configured, or because you have already replaced the department with D00 PD, we have got couple of columns from department data, right? So the couple of columns were department name and department head, even those will be having null values. So what I'll do is, for PD, whichever is my null value, in department name, I'll go and put the concerning record. Say, for example, I'll just show you department data here one more time. Sorry, it should be here. Why is it taking a lot of time? Oh, the GAD. Okay, so if I look at where is PD, let me get 10 records. PD. Damn, where is PD? Get 15 records. Yeah, PD is there. Okay, so the PD department should belong to product. Department name should be product, and department head should be Shishant. Darcy Stains. So let me go and replace it. Not sure why it did this, but let me go and replace it with respective values. Okay, so wherever I have PD department, I'm going to have department name as product, and the department head has Darcy Stains. So I'm going to do that. Now let us see the null values again. Employee data dot is null dot sum. So department is 0 null values. Department name, again, we have a couple of null values as 207. Department head again is 207. Let's see why we have like that. Okay. Let me go and check the null values there. So what I'll do is I'll go and copy this code. Where we have dpt underscore name is null. The meeting is going to end. We can restart the meeting. I'm going to fetch this and I'll see department is IT. And in IT, we do not have department name and department head. Okay. So I'll just go and replace the respective values with department IT. Why it did not match? So let's go back here. We'll copy the same thing. And I will paste it here. In this case, it should be, instead of PD, it should be IT. What is the name of IT? You know, the IT is IT and Henry Eddy. I'll just copy this. I'll go back here. It is IT
Henry Eddy.
Henry Eddy. Okay, I'm going to replace it. You already know this, so we don't have to worry about it. So let me go and see the null values one more time. When I look at it, I don't have any null values in department name. I don't have any null values in department head. I don't have any null values in department. This is how you treat with categorical data. Now let us take one more data, which is nothing but a filed complaint. Now in filed complaint, when I look at it, I have a couple of values with. So how to get value counts is by using dot value counts. You take a series followed by dot value counts and specify that if you want to drop the NA or not. So I'll say drop NA is equal to false. When I do that, I'm going to get number one records are 2046 and the null values are 12,104, which you notice here as well. Filed complaint is 12,104. It is obvious because whoever has complaint, the value will be 1. Whoever has not complained, the value will be 0. So in this case, what you can do is simply go and replace with 0. How to replace with 0 is by using dot fill NA. Okay, so now we have used dot fill NA. After doing dot fill NA, when I go and see the number of null records, I see that I don't have any null records in filed complaint. Similarly, let's go and see recently promoted or not. Again, it's the same intuition. If the person is promoted, you have 1, and if the person is not promoted, it's a null value.